Halo Solius.
Hello, Habibi.
Halo, good morning.
Good morning. Good evening.
Good evening for me. Yes.
So what you are going
Okay,
to show today?
this is actually one of the use case that I just built for our internal demo. So basically there is a questions from many people actually about importing Excel. Basically to import the Excel, right? Import Excel data to Catia Magic, right? We have several way to do that. Like for example, we can do the mapping, right? We have a capability to the mapping. We can also use the table. On the table, we can also do Excel synchronization directly on the table. But however, right, those default function, default feature, sometimes it does not meet the requirement, yeah, does not meet the requirement, especially when we want to play around with the custom element value, or if you want to play around with the string manipulation, right? So the problem that we try to solve here as the demo is how to import an Excel data. If the Excel data, for example, if some of the columns using a kind like pattern, or maybe if you can use a kind like delimiter here, right? So this is delimiter, and then we want to parse this value, this attributes value become multiple attributes, right? By doing maybe the parsing, doing maybe other string manipulation, right? So we can do that, right? We can do that with our Excel helper API. So the problem that we try to solve here from the source, we have a column name, the first column name, and then also the second column is attributes, right? And then the name, we will map the name to the name of the block or custom block here, the custom element. And then the attributes here, we will parse these attributes, and then we will fill these attributes to each of the attribute that we already prepared here, right? So this is we will do this with our Excel helper API and some scripting to parse the value, yeah, to manipulate the value. Now, so we prepare step by step, yeah, simple step by step. So for examples, the step one, we have the 4 step here to do. I'm demonstrate, the customization by using a custom profile. Actually, we have another way to do this, but I will explain you why I use the custom profile, why I use the custom attribute, and also use the capability of our magic model analytics, yeah, to create a kind of like opaque behavior or opaque action, right? So I will show you the reason why I use this customization method, yeah. So we just directly go to the demonstrations, Solius. Maybe you have some questions, Solius, about before we go
No,
some
I'm
comment.
much interested in the demonstration.
Yeah, yeah. So basically, right, in order to generate the custom element, right? So basically, I'm creating a custom block here, a custom element or custom stereotype. You can either use the meta class, from the class, or you can just inherit from the block. Basically, it will be fine. Yeah, both of them are fine. The important part of here is you might notice that the way I do the element generator here, I directly create two attributes stereotype, two custom attribute for stereotype to define, the meta model of my element generator. Maybe you have a question, right? Why I'm not just using the macro, for example, right? Why I'm not just using the macro in order to generate the element generator? So you might notice that, right? If I define the macro, if I'm using the macro, for example, you need to specifically define, the target the target, or maybe like a target package or the target stereotype, you need to define all variable here, right? You might either use the, the human name, or you might use the fully qualified name here. You might use the string, or you might use the element path. So it means that you play with the string manipulation in order to find the owner package, or maybe the target stereotype name that you want to generate, right? So instead of doing all of that, searching, recursive searching into the containment tree, so why you not just create the meta model of your element generator, and then you can directly define, the attribute, the package, the target package, and the target stereotype, and then you don't need to do searching anymore in your macro. You just directly get this tag value. Later I will show you how to get this tag value from the stereotype. Yeah, from the stereotype value. So that is the reason why I'm not using macro, but I'm using custom stereotype to define the meta model of my element generator, because it will be easier to reuse again in the future. Yeah. And then from the custom profile, so you already define your element generator, which you can reuse later for the future use. And then you also prepare the custom block, the custom stereotype. The next step is we have to create, the instance, the instance or the definition of that element generator. So let's say that this is the context of my Excel reader. So under the Excel reader, you can define all the import parameter or import attribute. For example, the file names, the sheet name, the row size, the counter. Yeah, basically, I'm using this counter letter to do the repetition. Yeah, until the end. For example, until the end of the Excel row. For example, right? The other reasons why I put all this, attribute of the Excel mapping into the value property, so you don't need to do hard code. We try to minimize hard code inside the scripting. Yeah, so that's the reason why, right? And then here, if you see, this is the tag value as the result of our the additional attribute that we defined before in the custom stereotype for element generator stereotype, right? So here you can directly select, where you want to import the block, yeah, where you want to generate the new element, and what is the stereotype, that the custom stereotype that you want to apply to each of that element, generated element. So that's the the context that we prepare. And then from the context, right, of course, we need to define what? We need to define the function. So the function that we define here, basically, it's groovy scripting. You can use opaque action, you can use opaque behavior, it doesn't matter. If you use the opaque behavior, you can also reuse them later. If you create a dynamic scripting, it means that you can reuse not only in this project, but also in the other project, right? But we try to minimize hard code for reusability to get higher reusability, yeah? So let me explain about this scripting. So if I go to the body and language of this, so you will see the type of the scripting here is Groovy. So we recommend Groovy, yeah, for the best performance in Magic Model Analysis. We always recommend Groovy. So under this Groovy scripting, you will see I import two package, yeah, to library. First is from the application. I need this application because I need the information of the project. I need the information of the project because later I need to create the element factory. So that's the reason why I need to import the application. And then the second one, I need also the stereotype helper, because later on, once you generate the element, you need to apply the stereotype, the target stereotype, to every element that you generated by using the element factory. So if you see here, first I get the project. This is the basic, the basic command line that you need to always put if you deal with the project. And then the target stereotype here, as you can see, I use the action language. So the action language allow you to get the tag value, the tag value that sit under the stereotype. So for example, if I have this target stereotype as the tag value of my custom element generator, so it means I can get those stereotype. And then the same as the package, I can also get the target package. That later I will use as the owner, as the owner of my generated element. So this is basically all the important information that I need to find first. And then, of course, when you play with the Excel, when you play with the spreadsheet file, right, you will deal with the row. So it means that you need to have a kind of like a counter. You need to play with you need to do a kind of like a repetition, looping, right? And of course, the first element that you need to find is the row size. It means that you can get the row size of that file by using our Excel helper API. You just use Excel helper dot get latest row number, and then pass the file name and also the sheet name that you get from the value property of the element generator block. And then if you want to do kind of like debugging, you can debug them. Yeah, you can debug them, and later on you can see from the simulation console. Not from this one, from the console. Yeah. And then after you get the row size, yeah, if you can do the looping repetition. Of course, this is the basic, the basic script to do the looping. So if you use Groovy, basically you don't need to specify, the how to say this one, yeah, the type, the data type for each of the variable that you have. You can just use def, right? So it means normally it will detect automatically, yeah. So row counter equals to minimum counter, so you can define the minimum counter. The minimum counter that I use here, I think is supposed to be 1, because 1 or 2, yeah, let me check, yeah. So if you see the minimum counter here, I use 2 because I want to skip the header, right? Because I want to skip the header. So you can do that. Now let me open again. So and then minimum counter, and then you do the looping, yeah, row counter plus plus, and then you check if the row counter value is the same as the row size. It means if you have 3 row, it will show up in after the row counter reach on the number of 3, right? And then from each of the row, you get the name by using the Excel helper dot get cell value. So it means that you will play with every cells, yeah, from the row and column, yeah, from row and column. So the column part is actually the last argument that pass into this function, right? If you see 1 here, it means it should be the column 1, right? The column 1. 2 here, it means it's the column number 2, the second column, right? And then you can also do the debug again. Now, the most important part here is actually the string manipulation that you want to do with this string value, right? In this case, because I want to do the parsing by the delimiter of the semicolon, so it means that I can use the string array, create the definition of the string array of the string, and then do the string split, yeah. This is a basic Java command, and then you tell the delimiter of that split function, right? And then from there, you create the element. Of course, you first need to create the factory, the element factory. There is something that you need to also aware here. When you use the element factory, it is suggestive, yeah, suggested to do error handling, yeah. But I'm not showing you the error handling here because I want to simplify the demonstration. The reason why we need the error handling, because imagine once you do the element factory and then you generate an element, like for example here I use the element factory to create a class instance. Why class instance? Because block is actually have the, is apply from the class meta class, right? So that's why we use the create class instance. The reason why we have to do the proper error handling. So once you create the class instance, and then you need to add stereotype, you need to set the name, you need to set the owner. If anything's wrong, anything's wrong, you can use the error handling to cancel, to roll back. Maybe you roll back, or maybe you cancel all the operations. So it's not cause you the error that the element does not have name, or the element does not have the owner. It become a zombie. It becomes a zombie element. So you need to have a proper error handling when you use the element factory. So from there, you add attributes for element, right? Of course, now you can have a repetition, a repetition, a looping inside the loop. For this case, you want to split, after you have all the ID with S, it means it's the plural, multiple ID here. And then you want to do a kind of like, remove the white space, right? Remove the white space, remove the bad character, for example, right? To ensure that your ID has no white space, no bad character. You can play with the regular expression, for example, to remove that. And then you can use the stereotype helper, and then you can use the function set stereotype property value in order to apply, to put the value, to set the value of the ID for each of the attribute, the ID that we already prepared under the custom stereotype. So you can play around with this function, with this string manipulation, depending on your requirement. That will be the end of the explanation of how you can reuse, or maybe remake the script for other use cases. Okay, so now after I explain you the script itself, now what I'm going to do is I'm going to import them. So now you see here it's empty, right? It's empty. There is no generated element here. Now what I'm going to do, I'm going to open this, right? Is a function, and then I'm going to run with context. Yeah, so everything, there is a 4 row. Why 4 row? Because if you back to the Excel, right? The row size is starting from here, 1, 2, 3, 4, right? So we start from the second row, third row, and fourth row, column 1 and column 2, right? Because we play with the cell, right? Now, after you will see there are 3 custom block generated from the by using the script. And then if you go to the import result, and then you refresh the table, you will see the name. You even see the apply stereotype, and then all the attribute, right? Map to from the as the result of the parser, from the parsing process, right? So that's it. That's it on about the Excel helper, using Excel helper API, and then string manipulation together. I add some note here in my slide here. So there are some possible future improvement that I'm thinking. For example, maybe there is the questions like, can we do two-way Excel synchronization with the Excel API? Of course, you can do, but you must be able to define the pattern. You must be able to define the rule. Without defining the pattern, you cannot create a dynamic scripting to avoid, the hard code and increase the reusability of the function, right? And then previously I just show you on how to create new element, but I didn't put any if else condition to check if there is any existing element, maybe with the same name under the same target package, for example. But of course you can do those kind of check. So why we need to do the check? Because later on I want to update if the existing element, the element is already exist under the same target package. So for the second synchronization, you just can update them or maybe delete them if the value is maybe gone or something. So that is the end of my demonstration. I hope it's helpful.
Very clean demonstration. One question: why is the Excel file? Should it be located the same package as a project file?
Yes, it's same. Must be same location in project file. But however, I used to do a kind like, I don't know, create a custom location like that. But you need to play with the project directory path. We can do that because we can get the project directory location and then do the manual parsing, string manipulation. If the Excel file is located, for example, under a specific path inside your computer, inside your local computer. But by default, it must be set under the same location. Let me show you
What
here.
if it is inside of the project file?
Inside the project file is supposed to work. Yeah, it's supposed to work as the attached file, right? Yes.
Yes, attached file.
Yeah.
One more question. So just to clarify, this is one-time import. It's not update, right? It would require to search element by ID or something to.
Yes.
Yeah.
But we can
Okay.
update. We can update. You just need to add. I think you just need to add one if else condition, and then you need to do searching. Find element by maybe by name. Yeah,
Okay,
you
very
need to do
interesting.
searching and find element by name. There is a one function in Catia Magic Open API to find element by name. Yes.
Useful lesson. Thank you.
Yep.
Very